In this series of videos I'm attempting to repair and restore this HP9845B vintage computer. Currently I'm working on the two internal tape drives in this unit, and they have been giving me a bit of a runaround. I had intended to look at the tapes themselves in this video, but I'll now do that in the next video. In this particular video I'm going to be looking at a few of the faults I found with these tape drives and the control boards. A couple of interesting faults have come up that I thought you might find interesting. And firstly, just to cover a few of the previous repairs. One of the control boards, I'd found a faulty transistor, and I needed to find a suitable replacement for it. So that's, looking at the schematic, is this component, and it needs to turn off quite quickly so that it doesn't artificially extend the pulses that are being generated. And so that really means that because it's being driven pretty much into saturation, it's really the internal capacitance that's going to dictate the turn off time, which really means high frequency RF transistor should do the job. So I've had a look around and tried a few tests on this, and I've opted for a BF200. It's quite low current gain transistor, but it's 700 megahertz. But most importantly, it's got a capacitance, internal capacitance of about 0.5 picofarads, so it's extremely low capacitance, turns off very quickly. It is a 4-lead transistor, but one of the leads is only connected to the metal can, so I've just cut that off and used it as a standard transistor, and it does seem to work extremely well. The next thing I looked at was one of the tape drives I mentioned didn't work, and that was this one. And so the issue I had with this was that if I tried plugging this into the control boards, then what would happen if you tried to issue any commands that would try and move the tape? It would start up, run for about half a second, and then stop. And that's normally a sign that there's no output from the tacho. Also, when I was running the test ROM, it couldn't see the end of tape hole. So what you have on this drive, ignore these white things, they're just plugs. It's this hole here, and that is a small incandescent light. Shines up. There's an angled mirror inside the tape cartridge that deflects the light, and if there's a hole in the tape, then there's a sensor here in this hole that detects that light, and that's what's used to detect the end of tape holes. And it couldn't see that. Now, both of the comparators that are used for sensing the tacho and the end of tape holes were faulty. So as you can see, I've replaced them, fitted a couple of sockets, it would then see the end of tape holes if I manually turned it, but I still had the fault of no tacho output, and it would run for half a second and then stop, irrespective of which command I issued. And that turned out to be a faulty sensor. So you've got this tacho sensor here. Just grab the original one. So very small sensor, I don't know if you can actually see that. And the strange thing is, I took this out and measured it with a multimeter, and it measures fine. If I connect a meter across this and shine a torch on it, block off the light, it responds and seems to have exactly the range I would expect it to, but in the drive it wouldn't work. Now you do have to adjust a resistor value. That's this resistor here. You can see I've fitted a couple of turn pin sockets so I could experiment with the value. It does say on the schematic that you have to set it for a certain level of operation. Had a 19k resistor in there, but whatever value resistor I tried, it wouldn't work properly. So what I did is replace that with a more modern sensor type. I do have some of the originals, but they're used in things like punched tape readers, and I didn't want to use them for that because they are quite rare and hard to get hold of. So I used one of these. These are standard modern sensor. But to fit it into what really amounts to a surface mount application, I had to bend the leads. So it's just really a case of bending the leads so that they're formed like this. There's a hole in the PCB. This is quite small, and of course it will fit through the hole. And with the leads bent over like this, you can solder them onto the tape drive in the original location, which is down here. And then I just put in a resistor. This is a 2.4K resistor, and it works perfectly. So this tape drive then started working. Also I modified the resistor value that sets the write current for the read write head, and this combination, I've left the original 200 ohm, I've got a 1K across it, and that gives me about 166 ohms, and that seems to work fairly well. Had already replaced the capstan, cleaned it up, and this now seems to work quite well. So that was a fairly easy series of repairs, but then I started working on the control boards, and this is where things got a bit peculiar. So found a few faulty ICs. This is the board that originally would lock up the HP when I tried to plug it in. The other board I've pretty much got working. That was really just the transistor. But this board was giving me some very strange behaviour, and although I've now repaired it, I have reintroduced the fault, and it took me almost an hour to track down the particular fault I'm going to demonstrate. You may recall both boards didn't work at all, and that was the dual comparator had failed on both of them. And replaced it on here, but then it started doing what I'm going to demonstrate next, and it's quite a strange fault that, as I say, it took me almost an hour to track this down. So I'll switch on the HP. And that's now warming up. Incidentally, if you're wondering what these leads are for, this assembly is normally bolted to the conductive case inside the unit, and it does rely quite heavily on good grounding, because you've got the small signals coming from the tape drive going through this ribbon cable, and also you've got power coming for the motor and the lamps, everything else, to the tape drive, and that introduces issues on the ground return path, and the noise exceeds the level of the signals coming from the tape drive. So without these ground straps, you'll get either very poor or no data output, even if everything's working. So it's just really clipping everything together so that there is good ground returns. As I say, if you don't do that, you'll struggle to get decent data out of the unit. So I'll now demonstrate this odd fault. I've got three tapes. I've got a standard DC100 tape and two DC2000 tapes. So I'll try putting in the first DC2000 tape, and I'll now just wind this forward a bit to make sure we're at the right side of the end of tape holes. And now I'm going to press the C key on the HP unit. Incidentally, I can drive this correctly in both directions. If I drive it forward, it works fine. I can stop that. I can drive it backwards. I can stop that. But notice the tape is still creeping along. It's still creeping and unspooling itself, so I'll stop that. The only way I can now stop this capstan from turning is to reset the HP unit. If we look at the pins on the D2A, these are the data input pins. You can see on the scope that the unit is doing what it's supposed to. It's not an analog fault as such. The D2A controller is receiving data from the control unit, and it's being told to apply an analog signal that generates the motor drive. But I can't stop this. If I try pressing the stop key, it doesn't do anything. The only way I can stop this now is to reset the HP. If I try a different tape, just need to mechanically reset the drive. put in a different DC 2000 tape and we'll do the same thing. So I'll drive it forward just to make sure we're in the right part of the tape. And now I'll hit the C key on the HP to try and read the tape. And once again it is continually spooling in the wrong direction. If I left it, it would completely unspool the tape. Again, I need to reset the HP to get out of that. However, if I now put in a standard DC 100 tape, just need to reset this again. That's normally reset by the eject button, but obviously we don't have that in place at the moment. So we'll put a standard DC 100 tape into the drive. I'll wind it forward. So I'm going to do exactly the same thing as I did with the DC 2000. And I'll now hit the C key, keep an eye on the spool, it rewinds. But it's now turning in the correct direction. This is what it should be doing. It's now reading the tape. And I am seeing data on the screen of the HP. And also I can stop this with the stop key. If I hit the C key again, rewind, and it's reading the tape. It is turning in the right direction. So I'll stop that again, take this tape out, just reset this, put in one of the other tapes. This is a DC 2000 tape. Wind it forward a bit. See, it's stopping because it's hitting the hole, because it wound too far the last time we used it. It's on the wrong side of the hole, which is why I'm winding it forward. Okay, I'll hit the C key, rewind, but once again it's now turning in the wrong direction. If we leave it like that, it will unspool the tape. And you can see the capstan is still turning, but it's doing this because it is receiving control data from the control unit. So I'll reset the HP, and it does this every time. Whatever DC 2000 tape I put into the drive, it will do the same thing. It's not because of the end of tape holes. They are correct. I've checked these very carefully and they're in the right place, the right height. It can see it. We know it can see it because firstly I've checked it with a scope, but also it stops when it gets to the holes. So it's stopping in the right place as far as the holes are concerned, but it's then slowly winding in the wrong direction, which is really strange. It's a very odd fault, and it took me, as I say, almost an hour to track this down. It's very odd. It looked like it was a fault with the tacho controller, so I actually swapped the tacho controller off the other board. So I took the four nuts off, and swapped the two control tachos over, but it did exactly the same thing. And I then started looking at whether it was possibly a fault with the HP unit itself, but there weren't any commands coming into the control board from the HP unit other than those for the start of the process. Checked for grounding, checked everything else, came back and it doesn't do it with the other board, the other tacho board, although one's a B and one's a C variant. If I put this board in, it doesn't do it, so it has to be something specific to the board. And I also tried the other tape drive. It doesn't do it. It does the same thing with the other tape drive unless we're on this tacho board, so it only does this with this particular tacho board. So I was looking around the schematic trying to figure out what could cause this. So it looked like maybe it was reading some data from the tape, or whether the DC 100 tapes had something written on them ahead of time, which I'm pretty certain is not the case, but it only does it with the DC 2000 tapes. Now, eventually my attention turned to this area, and partly the reason for this, let's turn the HP off, was that while it was doing this and while it was creeping slowly in the wrong direction, this heatsink was getting quite hot. I actually started off by smelling it. I could smell something getting warm, and I started looking around, and sure enough this heatsink was getting really warm. It wasn't getting warm any warmer than usual when it was driving normally, but while it was creeping forward, if I left it with the tape out for 3 or 4 minutes, this would get really hot. So it looked like it was trying to drive in 2 directions at the same time, and one was kind of winning out. And the direction this spins is determined by which polarity this op-amp works in. I put a scope on the output and I was getting it alternating between driving one way and driving the other way. But driving one way, it was trying to drive slightly faster than driving in the opposite direction. So the result was for the motor to slowly turn in one direction, but it was constantly trying to change direction, but one direction was winning. And looking at this device, although it's got the usual HP odd part number on it, this is U10, which is this. And if you look on here, you can't really find U10. And although these look like discrete FETs, they're actually part of a 4016 IC, which is this device here. You can see possibly it's in a socket. As I say, I did find the cause of this, and it was this IC. So this IC was faulty. I took the original out, put in a new device, and it seemed to cure the problem. So I'll just do that now. I'll swap the device. Okay, I've taken the original out. If you're interested, the HP part number on this is 18200981. But as I say, it's actually a 4016 IC. Turn the HP back on. Call up the tape test, and we'll put in one of our DC 2000 tapes. Wind this forward a little bit. Stop that, we'll press the C key, and it's now running in the correct direction, and I am seeing the correct data appearing on the screen. I'll press the stop key. We'll take this tape out. Let's reset this. We'll try the other DC 2000 tape, and if you recall, it did the same weird thing with both of these tapes before. We'll wind it forward a bit. Press the C key to try and read the tape. And once again, it's now turning in the correct direction, and I am seeing the data appear on the screen. We'll finally try the original DC 100 tape to make sure that one still works. And that is indeed still working, and I am seeing data on the screen. So a really strange fault, and I still don't really understand why the original tapes were working but the DC 2000s weren't. The hole is in the right place and on the tape, the spacing's correct, the size of the hole is correct. I was using a scope to originally fault find on this, and the correct data is appearing. The only thing I can see at all that's different is the acceleration of the DC 2000 tapes is very slightly slower than the acceleration of the DC 100 tapes. That's the only parameter I can find anywhere at all that is different. It didn't seem to be the signal level. I tried messing with the level of the data coming out to see if that was anything to do with it. Whatever I did made no difference at all. It just seemed to be something mechanical about the DC 2000 tapes. Now of course the spool is heavier. They do take a bit more torque to drive them, not much but a little bit. It does tend to make the acceleration rate of the system a little bit slower. So it could well be that for whatever reason the rate of change of speed using a DC 2000 tape along with the fault of this particular device was causing an issue. Now this device does test as faulty. It is switching, but it's switching very slowly, so I've got a feeling there might be a significant overlap or something, and for whatever reason it was upsetting the entire system. and it was actually locking up. You couldn't access the other test. You couldn't stop the test other than by doing a full reset of the HP. So something fairly bizarre going on with that, and I thought you might be interested in seeing a bit of a strange fault. But now these do appear to be working. I'm getting data. I can read and write data from and to the tapes, whether I'm using a DC100 or a DC2000. They now seem to be working, and so in the next video I will look into how we modify these tapes to work in these drives.